simple harmonic motion, I would give 2 stars out of 5 for difficulty. Simple harmonic motion occurs for, an example, a pendulum. It moves backwards and forwards, and its displacement is always in the opposite direction to its acceleration. So if we explain this on a graph, there's 4 points in time, 1 to 4, and the black line represents displacement. So we have displacement goes away from this is the equilibrium position, the x-axis is the equilibrium position. So displacement goes away from the equilibrium position and back, and then away in the other direction and back, away in the other direction and back, away in the other direction and back. Acceleration, as I said before, goes in the opposite direction, so it's an inverse graph, so it goes the opposite way. To show velocity on the graph is, if you need to think about when is the maximum velocity and when is the minimum velocity. So the maximum velocity would have to be, so if I show on a diagram a pendulum as it passes through the equilibrium position, it's just moved from here. As it passes through the equilibrium position, it must have maximum v, maximum velocity, because it's gone the most, it's gained the most kinetic energy from, the most kinetic energy has been converted from gravitational potential energy because it's in the exact equilibrium position, and it's not lost any, or no energy has been converted to gravitational potential energy yet because it's not gone up. So if that's the case and the equilibrium position is the maximum velocity, then we can say that at 0 here, when acceleration and displacement are both 0, which they always are both 0 at the same time, velocity must be the maximum. And because velocity is a vector quantity, it must have direction as well as a magnitude. So at some points it must be the opposite direction. So when it comes below the equilibrium position, it doesn't mean to say that the velocity is actually decreased. It's decreased up to the equilibrium position, and then here, although the graph is going down, it's still increasing just in the negative direction, which is this way. So if we carry this on, making sure that every time these two lines cross over, every time the displacement and acceleration cross over, the velocity is maximum. Carry this on. Then we get an overlapping of graphs.